We'll proceed in vector and commercial calculus. Vector and commercial calculus. I won't say calculating the area vector is pioneer. There will be pioneer more than that. That will be calculating the volume vector, that is three-dimensional, and then calculating more towards it. What we have achieved now. Okay, what what we were trying to do. We are trying to calculate area vector, area algebraic vector, area vector. Okay, so if I have a flat area, then area vector is easy. If I have a flat area, this is considered. So we are in phase to calculate area vector. What is area vector? What is displacement vector? These are the kind of question that arises. Why? What is area vector? What is displacement vector? What are you talking about? Displacement vector is pretty simple, right? Means this is x-axis, this is y-axis. Consider like this. This is this is x-axis and this is y-axis. In that sense, this is I plus j. I found it. This is the if item is moving in this direction, then this is I plus j. Very, very true. If there is a line called y equal to x, there is a straight line that is y equal to x. If there is a such line, what is the vector form of it? I plus j. I plus j is a vector. There is a force field. Whenever we go with the line integral, then we talk about the energy calculation. Whenever we go with the area integral, then we talk about flux integral. Generally in book, people would find a topic like line integral. People would find topic like a flux integral. Line integral means line integral means how you integrate a vector field along a line. How you integrate a vector field along a line. What are you talking about? How you multiply how you multiply a vector field, a vector to another vector. How you multiply one vector with another vector. Okay, there are two ways. One way is that dot product and one way is cross product. This is what we are talking. How you multiply two vectors. This is called line integral. How you multiply one line vector and another area vector. This is called area integral. Makes sense? If there is a vector, how you multiply this vector with another vector? How you multiply this vector with another vector? Okay, that vector is along a line. Up. How you multiply these two vectors? This vector represents a line and this vector also represents a line. Then multiplication of these two, finally it will end up in line integral. It is called line integral. How you do integ? Okay, so now this is line integral. The straight line can be replaced by a curved line. How you integrate this vector along this curved line? Hope. This is not a vector. This is a vector. This is called algebraic vector because this is a bunch of vectors. This is bunch of here vector is here this, here vector is this, here vector is this, here vector is this, here vector is this, here vector. Vector is along the curved line. So there are a bunch of vector. How you multiply this vector with a bunch of, okay, bunch of vector is not possible. Okay, then I'll address it as a algebraic vector. If it is I plus j, then it is one vector. But if it is xi plus yj, where x and y are variable, then it is bunch of vector. So algebra can be placed into vector also, xi plus yj. Now multiply this vector with another vector here, xi plus yj. Just say it, since it is variable xi plus yj. If this variable is along a line, then it is line integral. Okay, I believe it is crystal clear. Okay, another is that consider that it is variable along a surface. Okay, where is Mr. Surface? Okay, I have found better surface now. Okay, so this is a surface. This is a surface. Okay, I believe it is very small. We will take it through. Now consider I have to multiply this vector with this vector. Okay, how come it is? It is looks like a kind of some sphere or something like that. Okay, how I can represent it as a vector? This is a vector that I can understand. Then multiply this vector along this vector. Okay, this is consider this is centered at the origin, and in that point from origin, consider this there is a point like this from origin. Draw a vector like this. That is position vector. That is called surface area vector. Okay, here the tangential vector, tangent of this curve was a displacement vector. Similarly, tangent, I said tangent was the line vector. But here, if I take any surface region from center, if I draw a line, this is called area vector. Up, area vector. Now, area vector everywhere it is different because area vector will be perpendicular to the area. If this is the area, then this is area vector exactly perpendicular to it. If this is area, then this is area vector to it. If this is area, this is area vector to it. So if I take a sphere, area vector every point it will be different. That multiplied by this. Multiplication of a vector with area vector is called area integral. It is called area integral. And multiplication of a vector to a curve vector, not area vector, curve vector is called line integral. So we are in the discussion. First, we were trying to find. So we are trying to calculate flux. Flux. I believe I'll see it later. Flux. But anyway, idea is how I can find area vector. This is a big deal. This is a big question. How I can find area vector? How I can find line vector? If this is the line, if this is the line is a curve. Line is not a straight line. And this is if this is a circular line, then it is x square plus y square equal to a square is the equation of a circular line. Y equal to square root of a square minus x square is the equation of circular line. In that sense, can someone represent this circular line through a vector? Consider this is x-axis, this is y-axis. This is x-axis, this is y-axis. This is origin. There is a straight line called y equal to x. Y equal to x. What is the vector? I plus j is the vector. Vector which represents y equal to x line is I plus j. Okay, all right. Now consider I have y instead of y equal to x line, I have y equal to a square root of a square minus x square, non-linear. In that sense, how I can represent vector for a line that is y equal to square root of a square minus x square? It will not be a constant vector because the vector along this line, if I try to find out, then here vector will be tangent to the curve. Vector will be tangent to the curve. Vector will change. This vector is variable. It will be a variable vector. How to find it? Okay, to how to find it, please watch our previous video. Very detailed we have talked about. But anyway, in summary, if this circle is centered at the origin, this is the origin. Consider any point here, x comma y. From origin, if I connect this point from origin, if I connect this point, then this is called position vector of this point. That is xi plus yj. If I calculate differentiation of position vector, if this is position vector, if I calculate derivative of position vector, it will result in another vector. And that vector is the tangential vector at point x comma y. So if I have a position vector p, then dp by dx is the displacement vector. Okay, why? You have to, otherwise it will take a lot of time. So if I have a position vector along a curve, if I do dp by dx, or if I calculate derivative of the position vector, then dp, just dp, derivative of position vector, will result into another vector that will be a kind of displacement vector. Similarly, if I have considered this is centered at the origin, this is centered at the origin. From the origin, it is origin that is inside it, I take any point P here on the surface, and from origin, if I draw a straight line, and this point P here is x comma y comma z, where z is dependent upon x and y. This is x-axis, this is y-axis, and this is z-axis, x-axis, y-axis, and z-axis. In that sense, we have kind of point P on the surface. From center, if I draw a straight line, then it will be the position vector will be xi plus yj plus zk. Okay, all right. Z is function over xy plane. If height is z, this is x-axis, this is y-axis, this is xy plane. This is xy plane, this is z. Z is dependent upon xy plane. Okay, xy plane contains x-axis, y-axis. X-axis and y-axis are independent to each other. Z is dependent upon xy plane, means z is a function over x and y. We can write z equal to f, function small f, braces x comma y braces close. Function over x and y, that is z. We are in a phase, we are in a move to find the area vector. We found the displacement vector. If I have a position vector, if I calculate derivative of position vector, it becomes displacement vector, tangent vector, that is displacement vector. I have to calculate derivative only with x, because x is only independent component here. Y is dependent upon x. That's why y equal to square root of a square minus x square, because y is dependent upon x. Okay, here, we have two independent components, x and y. Z is dependent upon x and y. If I talk about the sphere, then it is z equal to square root of a square minus x square minus y square. Z, that is the height, that is dependent upon x and y both. X is independent of y, y is independent of x. We are in a phase to calculate the area vector. Calculate the area vector. What is area vector? Now we know, if I am talking about a curve, if I get position vector, if I differentiate position vector, I get the displacement vector. Similarly, now I'll go in similar fashion what we did. If I get a position vector along the curve, if I differentiate this position vector, I should get area vector. Okay, position vector is not the displacement vector. What is the scenario here is, what we are trying with a line integral, consider there is a force like this. There is a force like this, and because of this force, there is one item that is moving from one location to other location. There is one item that is moving from one location to another location because of this force. If item is moving from here to here because of this force field, how much is the energy involved in this? Because of the force, how much work this force is doing to move item from here to here. Force vector dot displacement vector. How to calculate displacement vector is, get the position vector and calculate derivative of position vector. It becomes displacement vector. So force vector dot d of position vector is the net work done. Similarly, if we are trying to find out flux, flux means if I have a liquid that has a velocity, a liquid is passing like this, it has velocity, and liquid is crossing this surface, then how much is the liquid that is coming out of the surface? Volume per second. If the surface is meter square and the liquid velocity is meter per second, if I multiply velocity with this area, then it becomes meter cube per second. What is the flux means how much is the meter cube per second coming out of this hole when liquid is flowing like this. Then that is velocity vector of the liquid dot product with the area vector. Area vector is perpendicular to the surface. So here area vector is like this and velocity vector is like this. So angle is 0. So cos theta is 1. Velocity vector dot area vector is the flux. If I want to calculate area vector, because now problem happening is everything is algebraic now. Velocity vector may not be straight. Velocity vector would be something like this. Depend upon the, if this is x axis, this is y axis, this is z axis, this xy plane is considered as independent. There, if I take different x and y, depending upon that, this velocity will change. So velocity vector is algebraic vector. Similarly, this surface looks like a straight, but it will not be straight. It will keep changing as we change x and y, like this. See? Okay, can you give me one case study? Case study we are giving like there is an electrical charge. There is one electrical charge of charge q, and it is placed at the center of this sphere. Inside it, the electrical charge is kept. Now, electrical charge has electric field around it. Now, if electrical charge has electric field around it, then electric field is coming out of the surface. Makes sense? It is like, consider that it is like some fluid is coming out of the surface. Okay. Now, someone would ask that how much volume per second it is coming out of the surface. Okay, can you give me the velocity of the electric field that is radiating from the center? Yeah, I'm giving q into r vector divided by r to the power 3. Consider that is meter per second. Q, r vector, r is spherical coordinate system. At the center, r is omni, r vector divided by r to the power 3. So if you go more, then velocity or the electric field will start decreasing. That way it is r to the power 3. In that sense, if it is kept at the center of this sphere, through the surface, how much the, the electric field is coming out? Velocity multiplied by the surface area. Now surface area is not flat. Can you see? Everywhere surface area vector is different. Then we will go like velocity vector dot surface area vector is the net flux that is coming out of this. But since both are algebraic, now we have to go with integration. What is integration here? I don't understand. Velocity vector may be in algebra. It is in algebra. Q into r vector divided by r to the power 3. If I talk in Cartesian coordinate system, then q into xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. That is the velocity vector. What is velocity vector? We have xi plus yj plus zk. That is the direction of the electric field. What is your surface area vector? I don't know. What is my surface area vector? I don't know. Surface area, I was thinking it will be a flat surface and it is kept like this, and I can say it is along x-axis, it is along z-axis. But here, everywhere surface area vector is different. I don't know what it is. So we are talking how to calculate surface area vector. To calculate the surface area vector, now consider this is centered at the origin, and from origin you take any point P here, that is x comma y comma z. From there you draw a line that is position vector. So position vector is xi plus yj plus zk. The way we did in two dimensions, to calculate the displacement vector, we did differentiation of position vector. Similarly, here also we will do differentiation of position vector to try to get the area vector. This is the one path. You get the position vector in algebra, calculate the derivative of position vector, it will give you the surface area vector or curve vector. If position vector is in two dimensions, then it will give you curve vector. If position vector is in three dimensions, then it will give you surface area vector. So point here is x comma y comma z. So position vector is xi plus yj plus zk. Divide, differentiate it, calculate derivative of this. then you will get the surface area vector. If you calculate derivative, then you have to calculate derivative against some variable, right? Here there are two independent components, x and y. So let's derive with xy plane. So what is now, I know that if I do d of position vector, I get area vector. What is net flux? Velocity vector, that is qr vector divided by r to the power 3 dot product area vector. Velocity vector dot product with the area vector, that is the net flux that is coming out of the surface. Now area vector I can write as d of position vector. Differentiation of position vector is area vector. Now net flux is velocity vector dot d of position vector. D of p I can write as d of p by d of xy plane into d of xy plane. Same thing. As per multiplication rule, it will cut down, it will become d of position vector only. D of position vector by d of xy plane into d of xy plane. Okay. Now d of position vector by d of xy plane is how much? I don't know. Okay. Someone can guess, right? D of position vector is xi plus yj plus zk divided by d of xy plane. It becomes d of x by d of xy plane I plus d of y by d of xy plane j plus d of z. Z is function over x and y. Fxy, d of fxy by dxy plane k into dxy plane. And someone has guts now to find dx by dxy plane I vector plus dy by dxy plane j vector plus dz by dxy plane k vector. Not possible. Let's break. This is what we are saying. Let's break. Now, if I have any position vector p, then make a cut in yz plane and make a cut in xz plane. If you cut in xz plane, then it will become a circle like this. If you cut in yz plane, it will become a circle like this. Oh, eureka, eureka. We know it. If you bring in two-dimensional circle, then I can crack it. I know anyway. So now if I cut in xz plane, here is the p. Now if this is the p, since it is xz plane, y is constant. So now I can differentiate it, y is constant and xz plane, z is dependent upon x only because y is constant, z is dependent upon x and y is constant, xz plane, y can be 0, y can be 1, wherever we made the slice. So if I have a circle and point P, then I can calculate dP by dx. If this is the point P here, then from center, if I take this is position vector, that is xi plus yj, y is constant here, plus zk. Z is dependent upon x only because x is variable, y is constant. If this is the position vector, if I do dP by dx, it will give me a displacement vector here, tangent vector here. If it is in yz plane, if I calculate dP by dy where x is constant, it will give me the another displacement vector. So in that sense, if this is the point P, if this is the point P and this was the circle, if I calculate dP by dx, it gives me this tangent. If I calculate dP by dy, it gives me this tangent. So dP by dx is a vector, dP by dy is a vector. If I do cross product of dP by dx cross dP by dy, then it will give me surface area vector at that point. dP by dx cross dP by dy. If I do cross of two product, two vector, it gives me area in between, and there is a vector that will involve that is perpendicular to the surface area in between. Make sense? So if I have two vectors, if this is a vector and this is a vector, if this is a vector and this is a vector, if I do cross product of these two vectors, it will give me area in between. What is area in between? This is a parallelogram actually. So one side will be like this and then top will be like this. It will make a parallelogram. If you do cross product of this vector and this product, the parallelogram what is making, that area it will give, and it will give one that the area direction will be perpendicular to the parallelogram. If this is the parallelogram, this is perpendicular. If this is the parallelogram, then this is perpendicular. Perpendicular to the surface made by these two vectors is the direction of the cross product. So if I have dp by dx in xz plane, I made a cut, right? dp by dy in yz plane, dp by dx cross dp by dy at point P, it will give area at that point, whose direction will be dp by dx cross dp by dy, whatever we get. This is surface area. This is surface vector. Okay, but you said that surface vector is d of position vector. D of position vector, I made it d of position vector by d of xy plane into d of xy plane. Now d of position vector by d of xy plane, I can write as dp by dx cross dp by dy. Same thing. dp by dx, dp by dy, and dp by dx denominator becomes dxy plane only. Same thing. So dp by dxy plane, I can write as dp by, because dp by dx cross dp by dy. Here numerator by dxy plane. Net I can write dp, the area vector I estimated as d of p position vector. It becomes d of xy into dp by dx cross d of xy into dp by dy. Okay, whatever comes, this is the area vector. Now it is simple. Now I can differentiate with x and differentiate with y. Let's proceed. Anyway, d of xy and d of xy is common. I can keep outside. dx, dxy plane. dxy plane in Cartesian coordinate system, I can write, keep it as dx dy. That we will see later. dp by dx. What is position vector? xi plus yj plus zk. Okay, I believe it is all right what I am talking, sir. I would reiterate. So if I have a, kind of a, okay, so if I have a kind of a surface like this, okay, if I have a kind of surface like this, and it is centered at the origin. From the center of this, if this is point P, I draw a line that is position vector of this point P. If this coordinate of point P is x comma y comma z, then that position vector is xi plus yj plus zk. If I make a cut in xz plane and if I make a cut in yz plane, then it would result in two circles. One circle is in xz plane and one circle is in yz plane. Now in xz plane, y is constant. If this is the point, I made a cut and point, this is the point P, then this is position vector. That is x comma y comma z, where y is constant. Now, if y is constant, I can freely differentiate with dx. If I differentiate with dx, then it will give me tangent vector like this. dp by dx is this. Similarly, if this is if this is the yz cut, then this point is P and this is the position vector, then dp by dy will give this tangent vector. Now, if I come back to the point P here, then dp by dx is in xz plane, dp by dy is in yz plane. If I make cross of these two vectors, this vector and this vector, it will give a momentary surface area here. And direction of the surface area is at that point, what is the perpendicular. So surface area vector will be different at different points, perpendicular. If that is the scenario, then this is the surface area vector. dp by dx cross dp by dy is the surface area vector. Now, but we said our surface area vector is dp. The net flux coming out because of electric charge velocity vector dot d of position vector. That is the surface area vector. D of position vector I can write as dp by dxy plane into dxy plane. D of position vector by dxy plane, now I can rewrite as dp by dx cross dp by dy. After all, it is a multiplication. So denominator is dxy plane only. So now dp became dp by dx cross dp by dy into dx dy. Or I can say it is nothing but cross product. D of position vector is nothing but cross product of two vectors. One is dxy plane dp by dx cross another vector is dxy plane dp by dy. Anyway, dxy plane I can keep outside, and dp become dp by dx cross dp by dy whole multiplied by dx dy. Dxy plane I can write in Cartesian coordinate dx dy. What is dp by dx? Position vector p is xi plus yj plus zk. dp by dx becomes I plus 0 because y is constant. If you remember the way I take xz plane, so 0, and z is function over x and y, so z will remain there because it has x term also. So dp by dx becomes I plus dz by dx k. Cross product with dp by dy, j plus dz by dy k. So I plus dz by dx k cross product with d plus j plus dz by dy k. If you calculate this cross product, then it will become minus dz by dx I minus dz by dy j plus k. Okay, there dxy plane or dx dy. This is the area vector. So velocity vector dot product with minus dz by dxi minus dz by dyj plus k dxy plane or dx dy. This is full is the area vector. Tell me clearly the area vector. Okay. The area vector is minus dxy plane or dx dy minus dx dy dz by dxi vector minus or dx dy into minus dz by dxi vector dx dy into minus dz by dyj vector dx dy k vector. This is the area vector. Now, if this is the area vector, simply calculate the flux coming out of it in velocity vector dot product with the area vector. So, velocity vector is q xi plus yj plus zk divided by x square plus y square plus z square to the power 3 by 2. Dot product with the minus dz by dxi minus dz by dy dz by dyj plus k dx dy in braces dx dy. If you calculate this, you get the net flux that is coming out of the circuit. Okay, so someone can try that how much it will. Q is constant. Q is constant. I can keep outside. Okay, now the velocity x vector is x by square root of x square plus y square plus z square to the power 3 by 2 to the power 3 by 2 into d minus dz by dxi I dot product velocity vector dot product with the area vector. So it will become like minus x divided by x square plus y square plus z square, okay, power 3 by 2 dz by dx dz by dx. What is z here? If it is a sphere, z dz by dx, z is square root of a square minus x square minus y square. Dz by dx is minus x, so minus minus plus x into x square, x square divided by x square plus y square plus z square to the power 3 by 2 into square root of a square minus x square minus y square, I vector gone, plus y square. Similarly, y square, x square plus y square plus z square to the power 3 by 2 square root of a square minus x square minus y square, plus z, here z by x square plus y square plus z square to the power 3 by 2, and there only k is there, k, then dx dy. Okay, now someone is kind of free to do the integration. So x square plus y square plus z square. That if you see the last term, that is z by x square plus y square plus z square to the power 3 by 2. There it does not have anything square root of a square, x square, something like that. If we settle it down, it becomes x square plus y square plus a square minus x square. I believe I'm talking right. Okay, okay. So this becomes okay x square plus y square plus z x by whatever, x square by whatever, y square by whatever, plus z by square, x square plus y square plus z square to the power 3 by 2. If you settle it down, then it becomes, if you settle it down, it becomes x square plus y square plus z into square root of a square minus x square minus y square. So square root of a square minus z is again a square root of a square minus x square minus y square. Full will become x square plus y square plus a square minus x square minus y square. Everything will go away and only a square will remain there. So a square I can keep outside, q into a square. Now 1 by x square plus y square plus z square to the power 3 by 2 into square root of a square minus x square minus y square dz dx dy. Now x square plus y square plus z square. Z I can replace with a square minus x square minus y square. Then full thing will go away. A square square a will come into the picture. A I can keep outside. A square was anyway outside. They cut each other and it become q into a. Integration of 1 by square root of a square minus x square minus y square dx dy. Now, someone can go this with polar coordinate system, something like that. Consider x equal to r cos theta and y equal to r sin theta. In that fashion, it becomes 1 by square root of a square minus r cos square theta minus r sin square theta. Okay, if that is the case, then it becomes a square minus r square. 1 by square root of a square minus r square. That will remain there. And there, dx dy, it becomes a dx dy, x equal to r cos theta and y equal to r sin theta. This is what I believe so. Okay, someone can proceed. Then dx equal to r sin theta and r cos theta, something like that. Okay, in that fashion, it becomes r dx dy. Okay, someone can proceed. Okay, I'll try doing it. So this is how it is. So, or if someone is very good, then out of the way he can try 1 by a square root of a square minus x square minus y square dx dy. Let's consider that y equal to x equal to square root of a square minus y square, x equal to square root of a square minus y square cos theta, x equal to square root of a square minus y square cos theta. If you substitute here 1 by square root of a square minus x square minus y square, then x is x square root of a square minus y square minus x square. X I have taken square root of a square minus y square cos theta. Now it becomes a square minus y square cos square theta. So a square minus y square, I can take it out. Okay. So it becomes 1 minus cos square theta, square root sin theta. It's become 1 by square root of a square minus y square into sin theta. Now dx, x is the square root of a square minus y square cos theta. Dx is the square root of a square minus y square sin theta d theta minus sin theta d theta. In that case, sin theta gone, square root of a square minus y square gone, minus will remain, that I can keep outside. Now it becomes d theta dy. D theta integration is theta. D theta integration is theta. Now theta, someone has to try. Theta means x equal to square root of a square minus y square cos theta. Theta is cos inverse x by square root of a square minus y square. Now integration is done. So dx integration is nothing but dx integration is cos inverse x by square root of a square minus y square. Okay, if that is the case, then x, okay, if I'm trying for the calculating the surface area, okay, then x, if I see from the top, because xy is an xy plane, then that is a circle. X is minus a to a, and y is minus a square root of a square minus x square to a square root of a square minus y square. Or I can take reverse fashion. Y is minus a to a, and x is minus a square root of a square minus y square to a square root of a square minus y square. If I do like that, then cos inverse x first will be a square root of a square minus y square. Cos inverse 1. Cos inverse 1. That will be 0. And another will be minus cos inverse minus 1. Pi. 0 minus minus pi. It will become pi. At the end, it will become pi. Okay, pi and then dy. Integration of dy is y minus a to a. 2a pi and a square is settled and cube. That will be the net flux that is coming out of the sphere if charge is kept at the center. Okay, someone can try in neat way. I would also try, and same thing I can produce in neat way. We will go with the more example on it, but inference is the surface area vector that was d of position vector is nothing but dp by dx cross dp by dy whole multiplied by dxy plane or dx dy. Net flux is velocity vector d of area vector. D of area vector is, sorry, velocity vector d of velocity vector dot product with the area vector. That is velocity vector dot product or d of position vector of the area vector. So velocity vector dot product with in big bracket dp by dx cross dp by dy dx dy. That is the net resultant, and integration over the xy plane, whatever the area limit is. I believe we will do some case study more on it, and then it will be clear. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.